Welcome to the somewhat monthly WebGL San Francisco-based meetup. I'm Tony Fabrice, the organizer. Damon Hernandez, my co-organizer, is right here manning the video. Say hi, Damon.
Hi, guys.
Great. And tonight we're going to be talking about COLLADA2JSON as well as WebGL TF.
William,
you're on my door.
William, you're on door duty? Thank you. With our featured speaker, Fabrice, I'll introduce him momentarily. First up, I want to thank our sponsors, the Kronos Group. They always pay for the beer and the pizza and all the goodies. You can have that shit. And before we do that, I also, before we get into the presentations, want to thank our gracious hosts, Mark Danks, Sarah Stocker from 3D Systems. Thank you very much. I'm actually going to have them speak to you a little bit and tell you about what 3D Systems is doing, what they're doing with WebGL, which is incredibly exciting. And we'll take it from there, guys.
So the last time that we saw you guys, well, when we were standing in front of you instead of watching some of your awesome presentations, we were telling you all about our startup, MyRobotNation, where we essentially, in the browser with WebGL, were able to create your own personal robot and then print it with 3D printing to let you hold what you've created in your hand. Which we thought was really innovative and amazing and incredibly risky. As Ken, we are often quoting him saying, gee, WebGL and 3D printing, what could go wrong? Well, it turns out not a lot went wrong and a lot went right. Betting on WebGL was absolutely the right thing for us to do. An amazing, amazing push forward into the future for the technology that we started with. And less than 5 months? 4 months after we launched MyRobotNation, we got acquired by the biggest 3D printing company in the world, and that's 3D Systems, who's building you're standing in right now. And the brilliant and innovative people at 3D Systems asked us to lead their consumer division so that we could bring this kind of technology and much, much more to consumers worldwide and democratize creativity around the globe. That's been an amazing journey in the few short months we've started it, and something that we think is really going to change the world. And it all started with WebGL, and it started right in front of most of you guys in this room.
Yeah.
So while 3D Systems is a big company, the main thing we're doing here in San Francisco is sort of all the consumer-facing stuff. And one of the main things is our main website, which is Cubify.com.
That's Cubify.com. Visit, check it out, make stuff, buy it.
So you can hear sort of chirping in the back. We have a bunch of 3D printers. So those are the home printers that we have that you can buy there. And we just kind of have various things kind of crunching out and coming out of there. We'll show you some examples. But to sort of show, how this all works is we can say, go online, and we have a whole bunch of apps that you can go and play with and actually create. So one example I'm going to give, because we have some here that we might even be talking about in a minute. If we wanted to come and make your own bug droid, so this is all WebGL, sort of running in a browser. So I can go here, create, if you know MyRobotNation, it'll look pretty familiar in some ways. But all this can be done, so I can forward it and change it. So it's the same technology we were doing before, and now we're applying it to different things. So we have a jewelry maker, we have these types of things as well.
It's really anything that is an object that you can turn and manipulate in 3D. We can bring into the engine, we can decorate up with stamps and other 3D objects. And as we told you, less than a year ago, this is really just the beginning. And we're expanding that out more and more through all kinds of different technologies that allow you to take your imagination and make it real. And again, this is really based on WebGL and using a browser for your solution instead of a download.
Yeah, so this is, if you sort of think this through, this is a major publicly traded company who's going, cool, we want to have all of our apps done this way. So we're actually, this is, you can't do this in certain browsers, and we're okay with that because this is where the future is, and that's what we want to be doing. So that's the kind of stuff we do. So
yeah, I wanted to show you guys some of the other technologies that we can do with 3D printing. As Mark was saying, we've got a really kind of desktop consumer 3D printer that you hear him buzzing away over there. You pull out the cube. The name of that printer is the Cube. That's C-U-B-E. You can search it on the web and buy your own for $13. You pull it out of the box, plug it in, send your model to the printer, either through Wi-Fi or the USB stick, and you can be printing out something like this. It takes I think that one takes a long time, like a 4-hour print. Or you can go up online to one of our, jewelry apps like this. This is a badge app. Our kids love doing this. I'm just going to show you guys some of the stuff that comes out of it. Get it there, put your initials on stuff, put little decals onto it, match it up with a keychain, whatever you want.
So like another example, I emailed Ken today and said, hey, do you guys have a WebGL model? And he said, yeah, here, go look at this. So I started printing out little WebGL things today. Yeah, because you can, it's cool.
Yeah, absolutely. Anything that you can imagine digitally, you can actually create in the real world now. This is unbelievably historical. This is something you're going to be telling your children or your grandchildren. You know, when I was a kid, we didn't have these things that just materialized an object in your hand, and they're going to be like, what? It's going to be like telling me you didn't have a cell phone or an internet. But that's just one technology that 3D Systems owns that we're able to open up to people now. This is basically using the same plastic as Lego pieces use. It's ABS plastic. Very, very flexible. You can make all kinds of things with this. You can stuff it in your mouth. It's really
we don't recommend that, but it is not toxic.
Other things that you can create with 3D printing are far more complex and detailed things, like these retail phone cases from Fresh Fiber, which is another division of 3D Systems. This is crazy. Check this out. This is made on a bed of nylon, and the laser goes through the nylon and sinters together all of the tiny grains of the nylon at superheat. And that object that they're passing around now has essentially got chainmail on the back of it that moves. It came out of the printer that way, in one piece.
So here's another example. This belt was not assemblable. You literally pull it out of the dust, you're done, ready to go.
Yeah.
So
These bracelets I'm wearing.
Yeah, there's no assembly required.
And you can buy
So do your robots have arms that move yet?
We actually have some that print on the cube that have articulated arms.
Yeah, actually we do. Yeah,
These guys. Yeah, so these.
That's a breakthrough.
Yeah, so these giant ones that are here are the exact same technology as the small ones.
Right.
We just printed bigger. These are more
Do
like.
Do you guys remember the last time we were here and they were little tiny ones?
Yeah.
So we thought we'd show off a little bit in our gorgeous space here and make enormous giant robots. These are all user created in the engine that's powered by WebGL on MyRobotNation and now on Cubify. So we didn't design these robots. These just come from little bits and pieces that users put together, colored, placed, and then printed out. Not quite this big. So the other, that's another kind of technology that we should point out, and really the one that brought us into the whole 3D printing world. Coming from the games industry, Mark and I are turned on by exactly the kind of things that you guys are turned on. Bright colors, complex shapes, that kind of thing. When we saw that you could actually make real some of the characters that we had in games and hold them in your hand, we had no idea that this quality and this level of complexity was available in what we consider to be a rapid prototyping tool, 3D printing. You guys may not know, but there's a huge industry of 3D printing in almost everything you touch every day. If you've ever gotten on a plane, you are relying on 3D printing for your safety. The rapid prototyping that they do for every part in there enables them to be as efficient as they are, saves billions of gallons of gas every year through all of the honing that they do through rapid prototyping. Same thing with dental work. Invisalign uses 3D printing to perfectly match their fixture to your teeth. So it's all over the place, but now it's something you can play with, which is way more fun and way more interesting to us. Little robots, little bug droids, whatever you can make, whatever you can imagine. You can make a lot of it real right now. So we thought we'd have a little fun tonight and maybe send some of this crazy stuff home with you. But of course you're going to have to jump through some hoops to do that because we are gamers. First of all, did anyone here actually buy or read a copy of Tony's book? Keep your hands up.
Yeah.
Oh, yeah. Okay. Our first winners. Fantastic. Keep those hands up. That's for you. And I'm going to have to owe you one, and you one. Okay, don't forget. I'll get you one later. Okay. And now we've got some trivia questions. That was a totally blatant.
Thank you. You on the back.
We have to take turns.
Yeah, that'll teach you to not read Tony's book.
Yeah, you can be walking
right here, sir.
Thank you, thank you.
Wait.
Okay, Ken wants to amend one of the ones they sent you.
Yeah, because I'm not 100% sure what the answer is.
Oh, excellent. Okay, so you're
Just like-
sending me faulty data.
Yeah.
Small.
No, you can read 3 out of the 4 ones.
Yeah, so don't read this
Don't read
one.
number one.
And Ken, don't read this one. Okay, and then hand it to Ken.
These are so geeky.
Yeah, good.
Okay, all right. I hope you guys are the right crowd for this. Does anyone know what year the WebGL specification was ratified? No, but it's super geeky that you even answered that question. Does anyone know? What?
2012.
And
I think you guessed,
got it.
but that is correct. But I'm sorry, you've already got
You
it.
already got it. That's cool.
Yeah, he's right because you read Tony's book. But I think you might have an argument.
He gets a prize.
He gets another prize.
What, oh, he copied
Here,
it.
He's
you
already
gotta
got
show
that. Oh, he's good. He's good. Okay, and I can read the second one. What does the E? Okay. Oh, this one slightly less geeky. What does the ES stand for in OpenGL ES?
Embedded system.
Who said what?
Back here.
Embedded system. Embedded system.
Who said it?
David.
Where's the flag? Here, you can be the distributor. My beautiful assistant Mark will pass out. Okay.
Take a book.
We're gonna skip the third one. Oh, and then we're gonna read the fourth one. What does VRML stand for?
Virtual reality markup language.
What'd you say?
Virtual reality markup language.
Adam said it too.
He said, okay, we'll give you the prize. He's already earned 3 of them. And gentlemen, I would like you to raise your hands. Okay. We'll see. Okay. A different kind of geeky. Ooh, this is a good one. 3D printing was used in what Academy Award nominated modern movie? Actually, I'm going to give him that, even though that's not what's written here, because that's exactly correct. Although I'm not sure it's Academy Award winning.
Sorry.
Ooh, but yeah. Does anyone know what the actual Academy Award winning movie was? Nope, but I'll give it to you for Paramount. Avatar. Did you know they used 3D printing to make and prototype all those things in Avatar? Paranorman is actually a better answer because it was using our Z printing, 3D printing and color, and they did all the little pieces of it.
All the heads and
Yeah,
eyes.
everything was done with 3D printing. Because you can imagine like all the stop motion stuff that you would do in like the Wallace and Gromit movies. Now imagine if you didn't have to move it with your finger, but you could move it digitally, print it, and film the stop motion that way. All right, so let's see.
And 2 more robots.
We got 2 more. Good. Okay.
I've got another question for you.
Where did the word robot come from?
Finally.
Who knows the answer to that?
It's actually a Russian word. No one else does.
Who? What?
Russian for
He's
word.
already got one.
Novel
Okay.
in the 30s about like Gorell.
It was a Czech word.
Yeah, you're right.
I'm going to give it to Robota, 1920.
It's word in Slavic. Very good.
Yeah, repeat offenders here. Okay.
Of course, Dave and I have unfair advantages. We have
All right.
Russian spouses.
I wish I could remember this. Yeah. All right, I'm going to do one last one. No, we got 2. Okay, you're going to read it. You're going to read it. You're going to read the questions that are right there. Do you got one more? So we don't have texture units.
I got one more.
You got one more? Okay,
just
you ask
say-
it. You ask
Okay,
it.
so what is the minimum required texture size in WebGL?
Raise it.
That is not correct. Oh my goodness, you might get it.
Raise your hand, come on.
See,
Keep on
now you see
testing
what
numbers.
else you do.
In other words, to say it more accurately, okay, if you want to upload texture to the OpenGL and WebGL implementation, right, it has to support at least a texture of a certain size. What is that texture size in WebGL today? It's not 1 by 1. 128 by 128. It's not 128 by 128.
16 by 16.
Ah, it is 64 by 64. Who said that?
Who said that?
Someone say it?
Yes.
I said 16, but.
Oh, crap!
Oh.
But it sounds like
It
it's
sounded like
64.
64.
Okay, all right, one more here. And because we're total, like, robot fans, we'll just give you this one here. There's a phrase from the 1951 science fiction movie, The Day the Earth Stood Still. Does anyone know the 3-word phrase that was uttered to the robot Gort? Who said that? What? Oh, please, God, I get another one. That's so good, though.
You could give them last one.
Dang. I think we got to.
Okay, we'll do it because we gotta move on to the presenters. Okay, so you want.
Because that is so super well earned.
Okay.
And then you can like, you can sell them on eBay or auction them off to these guys. Excellent. You guys are an amazing crowd. We have some great speakers for you guys tonight. So I think it's time to get them started. If you guys have any questions about how we did our thing with WebGL for MyRobotNation or anything about 3D printing and how it's going to change the global economy and the way we think and the way we buy and the way we make things in the future, feel free to grab Mark or I later. As you can see, we'd love to chat a lot about it.
Yeah, but they can't tell you anything because they work at a public company now.
Oh. Hey, give me a couple more beers.
Good, thank you guys. Thank you for hosting. I just think it's awesome that there's people with such passion for what they do that are at the heart of building real products with WebGL. It, to me, makes an old guy like me who's been doing it since the Vermal days feel really good because it was folks like that who really had all the energy that fueled a lot of development work, some of which actually made commercial success, made it somewhere. And I think this time around, sort of third swag at doing 3D in the browser with big folks behind it, with this kind of application energy and passion we're seeing, I just think we're going to see more amazing stuff like MyRobotNation. But I just think it's so awesome that these guys are doing this, and they're still doing it now with the resources they have, and they're going to bring 3D printing to everyone. So it's incredible. All right, before we get to our main speaker, Fabrice, I wanted to do it, not break with tradition here. We almost always get an update on what's going on in WebGL from the man himself. So I want to introduce Ken Russell. Ken is an engineer at Google, and he's the chair of the WebGL working group at Kronos, and he's going to give us an update on what's going on in spec, implementation, and so on from the working group. So Ken, thank you.
Hey folks. All right, so I will be brief because I have no demos this time. All right, try to do a couple of things. There's a conspicuous browser vendor that doesn't support WebGL. Why not? Because of security issues, right? So for a long time, we've been steadily working behind the scenes in various web browsers toward getting to the point where we can say, all right, we believe that our browser on platforms X and Y with these vendors' drivers is 100% bulletproof. Come and get us. All right. This is what we've been trying to do because we think that the only way that said unnamed browser vendor is going to agree to potentially support WebGL is if there's just overwhelming community. Look, what the hell? There's absolutely no reason for you not supporting it. We know for a fact that there are no actual security holes in the specification. If there are any issues, it's bugs in browser implementations, Chrome's included, as well as potentially graphics driver bugs that we have to work around. And we think that we're pretty solid. We are doing some remaining small work in the Chrome web browser right now to really put some strong sandboxes around what the content can do. Like if it causes the graphics card to reset, don't let it do that automatically ever again. All right. So these sorts of bulletproofing measures are being taken right now. So anyway, that's part of what's going on. Please.
Won't the named company then latch on to something else?
They may, but there's nothing else we need to latch onto. I mean, all of the issues that have been raised publicly about, oh, well, what about out-of-bounds memory accesses and other issues? They can't happen. The spec says that they can't. They can.
Like, the spec is bad. Like, it's not what we're used to.
Well,
it's something that has an accident.
They may agree to not, or they may decide to actually not support the specification, even after it's been demonstrated that there are no security vulnerabilities in it, right? But basically, once we can defuse the one remaining argument that they had, I think we're in much better shape. So anyway, that's what we've been sort of working on. In terms of
offering prizes or something?
Give them robots.
Maybe robots are making the Chrome security challenge.
Is it part of a Chrome security challenge?
Not yet.
Not yet. Okay.
I mean, we're not ready to make that statement. We are slowly and steadily working toward that. I anticipate within a month or two we'll have all the bulletproofing that we need in the browser to be able to say, on this operating system with this driver and this operating system with this driver, we think we're rock solid coming at us. That's
But that time frame,
a couple months. And aside from that, one big problem with making WebGL work the same, every browser, every operating system, is having the underlying graphics drivers behave identically for the ways that the specification exposes. And that sometimes, a graphics driver vendor will ship a new driver and it's got a bug in it, and we don't detect that until they've already shipped it, and it's already breaking Chrome, or it's already breaking Firefox, or it's already breaking WebGL. So for the first time, we've actually upstreamed to NVIDIA and to AMD and to Intel and to Apple, but Apple wasn't able to take it. The WebGL performance test bundled into a small package. It's a shell script. You run it, and it runs a web browser, it runs the tests, and it outputs pass or fail. That's it. It doesn't require any user interaction. And the good news is that it's actually saying pass for a whole bunch of configurations at this point. And the driver vendors are now taking this and putting it into their tests, so that they run this before they ship the driver. That would break WebGL, and they discover the bug before it actually ships. Hallelujah. So anyway, I anticipate that in coming years and coming months, we're going to see better quality graphics drivers that don't freaking break WebGL every time they ship a new Mac OS version or new driver version for various cards. And that's pretty much what I have to say. Any questions?
Ken, NVIDIA launched a new Linux driver this past week, which has had awesome statistics. I mean, they were doing 300 frames per second in relationship to our results or whatever. I mean, so do you know if their test, if you got into their test suite?
I'm sure that we didn't make the test suite for that driver version because we only gave it to them within the last couple of weeks.
Right.
But actually, the minute that we gave the test suite to AMD, they said we're already running it.
Okay.
Like within a couple of hours, they
Right.
required it to their test suite.
Right. So NVIDIA should be the same. Okay.
Any other questions? How are your applications working?
Is
Anybody got any bugs
this
in their
test
apps?
suite available right on Chronos and available?
Yes,
Okay.
absolutely. It's checked into the WebGL repository.
How do you run the tests? I mean, is it
Why don't we talk about that offline?
okay? I mean, I was wondering if a normal developer could use your ideas for running a test, and I could use it to test my app.
Why don't we talk about that?
Okay, right.
There was actually a recent bug that was found that was pretty critical. There's a recent bug that was found that was pretty critical. I was just wondering if there's any update on that.
Which
You know which one I'm talking about.
Which one?
Disable.
Disable the anti-aliasing?
Yeah.
Disable WebGL?
Anti-aliasing, yeah, by Brandon Jones.
Yes. So I posted on the public mailing list a couple of days ago, thereby really pissing off Mozilla because I hadn't realized that they treated the issue as a security vulnerability. We had to turn off smoothing of WebGL anti-aliasing on Mac OS and on Intel and NVIDIA GPUs. There are just graphics driver bugs that we can't work around there. So unfortunately, the quality for your WebGL apps is going to go down on Mac OS 10. You have affected machines. We're sorry. Please complain to Apple.
Is it all machines?
No, it's not AMD-based Macs, but it's anything that has an NVIDIA chip or an Intel chip.
Really?
It really does suck, yeah. Only Mac OS.
So this is a driver level issue?
It's a driver level bug. And finally, so Brandon Jones, who you probably all know from iOS Rage ported to WebGL and Quake 3 running in WebGL, he finally produced the reduced test case that doesn't even require a web browser that proves the bugs in a certain area of the OpenGL driver.
I just wanted to buy a reason as quickly you don't have to do anything, right?
Yeah. So anyway, you still need anti-aliasing even to look good on regular displays. So anyway, sorry, but these are the realities of trying to work in this environment. And we are hoping that by getting the WebGL conformance tests upstreamed to these driver vendors, that this is never going to happen again. Because Brandon also produced a WebGL conformance test that demonstrates the bug. So anyway,
So have you guys at Kronos created a benchmark for browsers for 3D performance?
there is a
Created a
repository.
benchmark, just a performance benchmark, that might push your odds on driver compliance.
Not yet. I mean, driver compliance is more a correctness issue than a performance issue. Right? All right, but there's a separate repository now on the GitHub Kronos organization called WebGL Perf that Mozilla originally created, and it's designed to test the WebGL implementation, issues like texture uploading and vertex buffer uploading, and we would more than welcome contributions to this test suite to expand it out, to improve the number of things that it's actually verifying. Any other questions? Please.
How do you feel about mobile devices next year, WebGL on Android and all the other mobile OSs within the realm? I mean, I know it's kind of in WebKit right now, but like in terms of being actually usable.
So, some brief update. As I mentioned during the last meetup where we actually showed finally WebGL running on Android, the two concerns from the Chrome on Android team about turning on WebGL by default are performance and robustness. Let's say robustness and then performance. Okay. I found a bug in NVIDIA's driver for Tiger 3 that was reported to them and fixed, but I haven't verified the fix. They verified it on their end, but I'd like to verify it here so we can definitively say yes, WebGL's rock solid on Tiger 3 hardware. Okay. Other ES vendors are getting on board with putting in the kill switches to make sure that WebGL content can't run off the rails. So once that's done, once we're pretty satisfied with the performance of the thing, it'll get turned on Android magically. Because Chrome on Android from top of tree WebKit is coming real soon now. The team's been working their asses off to get all of the stuff for Android into the WebKit repository. And it's really, really, really close to shipment. So thank you. Yes.
This is a Chromebook.
Yes.
One's WebGL, $249 computer. One runs WebGL fantastically. I'm not online, otherwise I'd show you.
Okay. There's a Wi-Fi code right there, Theo, so you can probably show everybody later.
Yeah.
That's great. That's awesome. All right. Thank you. All right. Now it's time for a featured speaker. So who here develops in 3JS today? Has built something 3.js? Any other toolkits, CJS, QBitVR, any of the other ones that rendered a WebGL? What? 3.dart. Okay, 3.js. So how do you create your content? Very carefully, right? If it doesn't work, you call Theo up and say, what the hell just happened? And he's going to go rewrite some code, right? We've all probably suffered from dealing with the vicissitudes of the 3JS format, for example, or the other formats that the engine support. We've tried, in fact, to load COLLADA files because all of them have some kind of COLLADA reader built in. But nothing quite works, and we talked about this at the last couple of meetups as well. We got a big pipeline problem. David Arondash over there and I have been working on some exporters out of some of the tools, Unity and Max, to kind of get somewhere, but it's still all really nascent. And I think one of the big issues here is to come up with a standardized way of at least dealing with the basic data that goes into many, many WebGL applications. Maybe not all of them. We may need some sort of custom format issues here and there, but by and large, people do things with meshes and textures and scene hierarchies a lot, like 90% of the time. So wouldn't it be nice if someone started solving that problem? Well, it turns out that somebody has been solving that problem, and that's tonight's featured speaker, Fabrice Robinet, who's from Motorola Mobility, and he's the chair. You're the chair now of the COLLADA working group at Fabrice? Yeah, and so the COLLADA file format, XML format, you guys may all know it. Fabrice is going to talk about it. It's been around for a while. Fabrice is fixing it. It's going to help make it work for WebGL. That's what that's going to be about. And so I would like you to welcome Fabrice up here.
I don't know the slides by heart, so it's not really good positioning. I don't prefer to face. so first, thank you all for me. I was not expecting so much before. It's great.
Do you want to take the other side so people can see the presentation?
Oh, you're
Yeah, sure. Yeah, that's actually perfect. This one. And thank you for organizing Tony and Damon and 3D Host for being our host, and to my co-worker and even some COLLADA working group member. I appreciate it. So today I will talk about COLLADA2JSON. Some of you may know this project from SIGGRAPH, where I've been presenting it during the COLLADA session and during the WebGL session as well with Cam. So it may have give you some hints about what it was, but now it's getting more concrete. So here is some context. It is an initiative actually from the COLLADA working group, and some of you may have seen the project landing this week into the Chronos GitHub, but this is really an experiment now. It's not a ratified Chronos spec, and this has to be very clear. So we all wait for your feedback and see what is your question and what you guys think about it. So about the background, in March 2011, Chronos organized a meetup with COLLADA and WebGL, and during the COLLADA meetup, attendees expressed the need for standard format with JSON. At least the need originally was how can we from COLLADA that allows to export and import the asset within the authoring tool. From there, how can I go to the web? And that was a big question that many of you have been asking, especially if you have mobile devices where loading COLLADA files with a lot of hierarchy will cost much of memory and horsepower to load, and we don't want to do that. So how can we bridge the gap? To answer this question, we have set up a few goals. The first goal is to really focus the effort on imported assets easily and efficiently for WebGL. For that, you will see a quick demo at the end of the presentation. Also, if it was just a polygon soup with some geometry, it could be not so useful, so you need some hierarchy to make actually something of interest in your application. And then the purpose was also to be able to load a CM. It means a SIGGRAPH and have some node in a very simplified way compared to what you could think about COLLADA, for instance, because this is clearly not a translation from COLLADA to WebGL. This is a very simplified view with the bare minimum that you need. And the last goal, there are also other, but say the last very important one is a seamless integration into existing engines. And for an example, I posted on Friday a mail on the public WebGL list to kind of announce this project. And on Monday morning in my mail, I had from Patrick Cozy, who works on map application with satellites and all that. I had him integrated the format inside his engine, so it's just awesome. And I will show you some demos. So just to give a concrete idea about what I'm talking about. Okay. Maybe you won't notice. So first there is the demo from Patrick, and this is the famous COLLADA doc because it's just the first update that comes up. But so it's a 3D asset, and now he can replace his satellite with anything he wants. Let's reduce. I'm sorry. Oh. Nobody. Okay, here is the Earth. So according to his feedback, he really likes the format, and he already started to contribute with pull requests on GitHub. It's really great to see that. I have another demo that I made with some of my co-workers here. Just to show you that you can, with this format, access to the scene in a hierarchical fashion. It's a scene graph, and you can change properties and all that. So it's just very basic, but just show you it's not only a polygon soup. You have the way to change materials, and you can click on different paths. You could do lots of crazy things, but I just wanted something simple and clean to demonstrate that. So that's the first demo. Let's go back to the slides.
Is that all polygonal, or does that have Bezier patches in it as well?
Sorry?
Is that entirely polygonal, that model, or does
Yes,
it have
yes.
patches?
No, it's only what you get for what can be represented for WebGL, of course. So at the end, it's only triangles, and what you get in the format is triangles. So how the guy made that in the authoring tool with patches or whatever before discretization, I don't care, I don't know. But at the end, it's just triangles. So the COLLADA2JSON project is made of 3 components. The first one is the converter, and it relies on the format, and eventually you can visualize your asset in a viewer. So far, the converter is pretty basic. It just unifies meshes indices because it is mandatory for WebGL buffers. If anyone don't really know what it is, just don't hesitate to interrupt me, but you're probably familiar with this kind of tweaks with your indices. And another thing is, another important thing is to have the rendering being a no-brainer, and you want for that to have the shader that matches this COLLADA common profile. But also, it provides you kind of meta-info of what generated this shader, so you could, for your deferred rendering engine, still regenerate your own shaders if you feel like. And finally, it bakes the matrices, and there is just one way of doing one thing for the transform so far, and maybe there could be other cases, but we start conservative.
You're only representing them in matrices?
Yes.
You're not storing the components separately?
No.
Good.
Well, it's good, but that's its problems too.
That's what I say. There can be discussions after. I prefer to start simple. And there are a lot of new steps to do with the converter. Obviously, the compression, improve the shader generation, and actually the shader generation is a whole project in itself. We probably know what I'm talking about here. And it's very important to split meshes to not exceed the unsigned chart limit for WebGL ES2, OpenGL ES2 and WebGL. But I think it's broken this limit with OpenGL ES3. Yeah.
Unsigned entities.
Yes. So, but anyway, we will have to under that. Also, some features should be included, like scaling, level of detail. So the reason why also there is not all these features included was to come up with something that displays the geometry where we can do some application, we can see the interest, but it's also good that the community contribute and can invest in it and can bring ideas so that it's not everything is not done yet. It waits for your feedback. So that's kind of areas that are missing now. And the converter itself has a few dependencies. It's cross-platform and it relies on CMake makefiles. the API to load COLLADA file is OpenGL, and to generate the JSON, it's rapid JSON. Let's talk about the format. So for now, the format is called WebGL transmission format, because I must confess that I had a lack of inspiration here, and the name will probably evolve to something else. And after all, this format also is suitable for OpenGL ES 2. So maybe it could be less specific to WebGL, but it's actually really a good fit for WebGL as well. So we'll see, and suggestions are welcome anyway. Here is a workflow. That's typical workflow where you have COLLADA that solves the problem of getting your asset out of the authoring tool, and then you use COLLADA2JSON tool to convert your COLLADA file into a WebGL TF file. And what is one nice thing that is not obvious here is we use the same API, OpenCollada, for both exporting the COLLADA asset and both importing it back into COLLADA2JSON. Because many people use the OpenCollada plugins, and even if it was not OpenCollada, it should work too with COLLADA2JSON anyway. But it's still good to know that it's very streamlined and very consistent most of the case, most of the time. And it's a final format for WebGL. It doesn't mean that it's the end of the format. It means that it really stands at the end of the asset pipeline. No transformation should occur. Everything should be ready straight to be sent to WebGL, and it's very important so that it's very easy for people to render something on screen. And the only exception that I thought about would be for compressed data if it's not handled natively by the driver. One of these cases could be today vertices and indices. And there is a nice project at Google called WebGL Loader, and we could use that project. So it's in the next step. So let's see what makes a WebGL TF asset. Mainly, you have the JSON file. It's central, and it contains the scene graph and some high-level entities. But more importantly, it points to external resources, and it describes how they are represented, and you will see that more concretely after. And there are external data like one external or multiple, if you feel like, binary file for vertices and indices, and that's very important. It means that the JSON file is very lightweight. You don't want to have a very big monolithic JSON file with everything in it. Here you offload all the loading of the big data, it could be compressed or whatever, and you'll see that at the end it's just a typed array. It's straight. It can be loaded straight with the XHR request. And you also have external data like images. So here is an example. In this screenshot, you see the smart car and one shared binary array, and by color you see that different parts of the car are actually all contained into the same array. So after it's up to the client to load everything in one array and change the offset or have multiple arrays or whatever. But what you can do is actually do a single request and load all that very efficiently, and you don't have any parsing or whatever. It's just an array buffer, and it's trivial to get the data after. Inside the JSON file itself, you have different kind of properties. First, the low-level properties, and these are the properties that you typically pass directly to WebGL, the buffer, indices, shader, program, and images. And then you have a combination of these properties like pass, accessor, and primitive. And on top of that, you have the more high-level one to get some sense of hierarchy, like node, mesh, camera, or like material and techniques. And you get this information from COLLADA, and it's translated in there, but in a very simple way. So we, as an example, we take the mesh property and see from the mesh to the typed array the steps that we have. And every properties follows the same pattern. So what is true for meshes in terms of organization is true for camera and lights. Obviously not for organizing the buffers, but running the logic inside the JSON file is the same thing. So each mesh is a JSON object. Here, you can see it. You have an idea of that torus mesh, so you can then in your application code retrieve that if you feel like. And it acts a bit as a mesh library, so you have all the same kind of object inside the same parent tag. And what's inside the mesh? You have the accessors and the primitives. For those who know COLLADA, that's something I borrowed from COLLADA, the accessor, because it's very convenient to describe stride and this way, because if you have just a buffer, you cannot say that you cannot specify the stride inside the buffer. And the notion of length is not relevant, so you need to have a count. So for these different reasons, you have the accessors. And after you have the primitives, which are a list of topological data, like you have triangles, triangular strips, or everything that you can pass to a GL draw element would be represented inside the primitives. And so I will go through quickly here, because we want to see the indices. It's the one interesting. In this case, for a given primitive, we look at the indices, and here we really reuse what exists already in the web. We reuse the typed arrays. And it's just a way to describe with the same properties than the typed array view with length and height offset. And it points inside a buffer, and you can load that buffer and then point into that buffer and take a specific subpart, and that's the way it is described. It's really in line with the typed array specification. So now it's a bit up to you if you want to have a look inside a WebGL TF asset. I can walk through quickly.
Bump up the point size on that. Can you make the text bigger?
Yeah. I don't remember what is shortcut.
You're in a browser.
I think there's an A right there. The A on the bottom. Is that what fonts?
Yeah.
I guess that's not fonts.
Yeah, okay. I already know, and I don't have nothing that works normally here. Let me see.
Control A and then button the sizes.
Yeah. I can do that, but I won't.
There you go. That's big enough.
Great.
Okay.
Thank you.
No problem. Let me see something of interest. Is there a specific part that you want to see?
Why don't you give us a tour, sort of quick
Yes.
nickel tour, and then maybe people can ask you.
So, for instance, in this particular asset, we have a single buffer, which is the idea of the buffer is supermodel.bin, and inside this, you have the byte, and you say, okay, that's a array buffer for the type, and then. As I was showing you inside indices, I will point to that buffer, and for these indices in this primitive, I will point to that offset, and it's actually a very short one, and that's it. I will draw like one triangle. Let's see the materials. Here I have a material, and for that material I have different inputs. Actually, I change that. Yeah, the format evolved a bit, but that's the idea. So you have the parameter is here, which is the diffuse texture, and you specify a technique, and when you retrieve the technique here, this one is quite large. And then inside the technique, you have a path, and for that parameter called diffuse color, you specify the symbol, and then whenever you change the parameter, the diffuse color will be updated, and you have the matching shader, which is also generated on the side.
What do you mean when you say every time you change the diffuse color? You're now talking about a runtime?
So you actually have one shader to do like a Lambert style shading, and you have different material which all use the same shader,
So
and
that's a uniform.
Yeah, and they have different values, each of them, for the diffuse color. So that's pretty much it. Okay. Back to the slides.
You want questions at the end primarily, or any time? So those bin files, those are vertex buffers. That's all the binary stuff, the float arrays and all that, right?
Yeah.
Is that one per mesh, or can you actually put multiple ones in those bin files?
It's one per file. That's what you show.
Yes,
right?
yes.
At the very beginning, it defines the points to the whole bin file.
It's up to you.
Multiple meshes.
It's up to you, actually.
Okay.
You can create in your exporter. You can make your exporter create just one single binary file for all the meshes. That's what I did. But you can create different one if you feel like.
Yeah, but it's another, whatever that binary format is that you're proposing here will support multiple things.
Yes. And if you want to have a closer look to the document, this is the URL, but it's easy to find on Google as well. I will now show you another demo. It's made with the super awesome montage framework, JavaScript framework. And here it is. So in this demo that you probably saw at SIGGRAPH, you see one of the characteristics of the format. Because you get the SceneGraph first, that is typically a tiny file, you can get it very quickly, but you may not have the vertices and ADCs ready yet. Say I just allow one concurrent request and I don't allow to merge the etc. requests together. That's what I was saying, what I was doing here. Then you will end up with a slower loading, and you will see that okay, this is a bit slow, but at least you have the good inbox information because of the SceneGraph already. So you can display something in place if you feel like. And you could also wait for everything to be loaded. It's your own cooking, but at least you can do that.
Does that mean you're saying the file's streamable somehow, the binary files? Is that what we just saw?
You have a description of each subpart of the binary file that you load. So if you feel like you can do a range request into a specific portion of the binary file, and this is what I'm doing here. So it really depends on the circumstances. If you may want to load everything at once if it's just a spinning object like this, but if you are in a big 3D world and you just want to load what is inside the first term, for example, so there is different use.
But does it assume the whole binary file has arrived, or can you somehow stream that? Are you working on any sort of protocol to deliver the binary file incrementally?
Didn't he stream it right now? He said
I saw progressive load. I don't know if
it's not really a streaming in the sense that I don't read float by float. Right now, I didn't use, for instance, WebSocket or whatever.
The whole file is already there.
No. I take a range request of a binary file, but this range request will give me at once a whole portion of the file. I don't stream float by float. You see
I
what
understand.
Okay.
Let me try and ask the question again. Was that whole binary file already on your machine, having been downloaded either from...
Yes, it's local here. Yeah.
So you haven't been working on any streaming delivery outside of that to the client server zone. The binary file was already just there.
Yes.
Right.
Yeah, and it's a good transition to ready, what we're saying. Because after you see with REST, there is much more possibilities.
Yeah.
It's all on his machine because the server is in the machine.
Okay, yeah. Cool. We can go offline with it. I'm just asking a basic question, but it's okay. I think I got the answer. Good.
Oh yeah, it's in local. It's one file. Yeah, we can continue after. Some more questions?
I'll start. Sorry.
Yeah.
I take up all the oxygen here, but especially since I'm near that fireplace and it's taking up quite a bit. Okay, you said it requires no transformation from WebGL-TF to WebGL. You said the goal of the format is that it requires no transformation.
Right.
I want to understand what that means, because what I saw were things like nodes and other COLLADA type structures that I know don't exist in WebGL. So clearly, those have to get translated somehow. So I'm assuming you're not talking about those. You're talking, for example, about the vertex buffers and the other low-level things that can just basically be slammed into memory with a binary read. Am I getting that right?
Yes.
Because plenty of the other things you mentioned require translation.
Yes, for me, I wouldn't put that into the same bag, the scene graph, which organizes the data, and the fact of having, for instance, with COLLADA, a multiple set of indices that you merge into a single one, and that I call a transform.
Right, so all that COLLADA type stuff you used to have to do to take everything from 12 different places and put it into a WebGL vertex buffer, you don't have to do.
Yeah.
It's going to be done in a binary
So
buffer.
what I'm saying is, when I have raw data, and this raw data goes straight to WebGL, and there are some data that organize this raw data, but to me it's not transformation, it's just organization.
No, that's good. Thank you for clarifying
Okay,
that.
no problem.
You show a viewer.
Yeah.
So is that a proof that it's worked? And if you can get it into, is that viewer available?
Yes.
Okay. So if you can get into the viewer, then you know you've got a good translation.
What do you mean?
Well, it's proof. I mean.
Yeah. So it's just a few test cases right now, so it needs a lot more
Right.
testing.
So,
but
I can use your viewer, try some experiments, and
yes.
if it gets into your viewer,
right. You need the converter to produce the WebGL asset that you have. You have to recompile yourself now, but I probably put a binary to ease that. And then when you convert your COLLADA asset, you will be able to put it in the viewer and display for yourself.
Right, and make sure that everything's okay.
Yes.
Right, and then you can bring it to your own application.
Yes.
The viewer makes a good sort of testing platform.
Yeah. That's it.
Okay.
Which program you use to export their COLLADA files? Because from my experience, I've written COLLADA importers before, is that all model editors seem to produce different COLLADA files that are like almost incompatible with each other. It's like you go to Maxix export one, you go to like Wave export one, you go to Cinema 4D, it exports a completely different one, and then you go to Blender version one. They had two different versions that are like weird. And it's like, how many formats have you tried?
So we are with the COLLADA working group, especially aware of that problem. That's why there is an effort from Kronos to make more robust the OpenCOLLADA API, and that's this API that is used actually. It was in that case it was just a COLLADA file from SketchUp that was exported, but most of the time I would work with Maya and Max. That's probably the use case I'm not telling me. And with these tools, I use the OpenCOLLADA plugin. I export a model and I import it still with the OpenCOLLADA framework underneath inside COLLADA2JSON. But for instance, it's here in all the models that you saw, models that I took from SketchUp. And typically the models from SketchUp are very simple, and the converter handles them very well. There are more involved models that probably might cause some issues, but for this model, it works great. And for the testing I had inside 3ds Max and Maya for simple models, it worked great as well.
Now, does WebGL is it going to have all the flexibility, and I'll put that sort of air quotes, that COLLADA has that leads to these issues that he's talking about, right? There's so many different ways you can output your COLLADA. It gets very tricky on import to be able to take in things from more than one tool. You end up just going with one tool because you can't handle the hassles that come with 5 different flavors of COLLADA. So is WebGL going to have all the same feature mapping so that it's one-to-one the same set of problems? Or is going through an open COLLADA or some other set of pipeline conditions going to help with that first before you get to WebGL?
It's a very good question. So the straight answer is WebGL is driven by WebGL. So anything that is out of the spec of WebGL in terms of the way we present polygons or whatever, that's not going into this format.
And there's really, you're representing the stuff in basically one thing, not
yes, that's why I emphasize on that. Just one way to do one thing, and we should have an excellent reason to do two things, the same thing, 2 different ways. Clearly. Thanks.
So any possibility to support more advanced materials and shaders beyond the COLLADA defaults?
You can put whatever shader you want. It's the format just lets you associate whatever semantics to symbols, parameters. You have the flexibility to do the shader you want. You have the flexibility to improve the converter, the generator that creates the default shaders and create some new ones and go crazy if you feel like. It's not tied to COLLADA. It's just that COLLADA is a really good test case for the input, but you can take another file format as an input if you feel like.
So I can have like more vertex data such as multiple images or
Yes, yes, yes. Exactly. You can. Okay?
So COLLADA has like other things like I think physics, animation keyframes, like all kinds of cameras and stuff. That's not supported by this one.
No, and
Because you can't do it in WebGL.
yeah, and that's the kind of feedback I'm looking for from the community. Yeah, I don't know really how far to go. It depends on the request, but there is a clearly a line which is the WebGL stack, and everything around is like convenience. For instance, to me, it's very important to have keyframing, for instance. So that would be something we could add. But I don't know, and skinning, but beyond that, I'm not sure about physics, for instance, but it's all open to discussion. Okay?
Great.
Okay, thank you guys.
Yeah, great.
Thank you. I so look forward to seeing the progress of this project. Did you tell folks how to get involved? If they want to get involved in this project, what's the best way to get going here? I saw some mail to the
yes.
WebGL dev list, but not to this group necessarily. So you might want to give folks URLs or something.
Yeah. So you go on the you can go on the Chronos group GitHub. So GitHub/Chronos group. You will find COLLADA2JSON, and there is already pull request. The door is open and IDs are welcome and all that.
Great. So please post that URL to the WebGL Meetup pages later.
We'll do that.
I'll project for that. Great. Thank you
Okay.
so much for listening.
Thank you. Okay, so now I'll let you introduce for me.
Yeah,
okay.
So we have one more little treat to add on to Fabrice's great presentation, which is I want to introduce an old friend of mine, Remy Arnaud, who's currently a PMTS. What is that, Remy? Premenstrual something? No, principal something. Okay, sorry. He's principal something or other at AMD, doing some work. But before he joined AMD, he's done a bunch of other stuff, including creating this wonderful COLLADA format that Fabrice's work is based on.
Everybody.
What's that?
That gives a lot of work
It creates a lot of work for everybody. Yeah, job security, folks. So Remy is the creator of that. He's an amazing engineer, old friend of mine, and co-chair of a working group that we informally created a while back called REST 3D, which I'm going to let him tell you about and give you an update on. Great. Take it away, Remy.
Thank you. So, yeah, I actually did the slides today. I wasn't sure I was going to present. But then I studied, Fabrice said he wanted me to do that, and it used to work. And he asked me to do a few bullet points, but then I decided to. When I was on to it, I just made a slide that I can't show you, so I don't know, how did we do that? Was it or maybe we need to switch to one, who was there?
Where's Mark? Still have Mark here? We need to switch inputs for that's a PC.
Is that VT I use, or is that, which one did I use? VT. I was using the wrong code.
Yeah. Right.
I didn't do that. I wish I did. Where's the play button? Right, so at this point it's more a refined idea. It used to be just an idea, and it refined a little bit. We have a mailing list on Google Group. We gather a bunch of clever people together, and we thought that was a good idea. And did a meeting at SIGGRAPH. There was a bunch of people there, and they said, well, this is an intriguing idea. So I'm going to talk to you about the idea, and this idea is going to be concretizing a little bit now because I do have time as part of my work to work on that. So for the last couple of weeks, so it's brand new that I do have time, but it's pretty cool that I will be able to see what can be done with this idea. So the I'm sure everybody is familiar with web APIs that are also called REST API or RESTful API. Some of those are RESTful, some of those are not RESTful. I'm not going to go into details there, but really the web that we know all today, the startups, the economy, the PCs, and all the energy behind the web is fueled by the API, by the fact that you can actually connect computers to computers. We talk about the Internet of Things now. And all those things are available as with services that you can reach out to from any of your applications or your website or your server. This one is pretty cool. That's the face recognition REST API. So you send your, that's acquired by Facebook not long ago. You send your picture in there, and it's gonna tell you if it recognizes the person based on all the database that they have. So all kind of services offered. Now, like I said, REST, a lot of things are going on in the web surrounded by REST, but what about 3D? And that's funny, I went on Stack Overflow and somebody said, is there a Google 3D Warehouse API? And the answer was a year and a half ago, and it hasn't changed since, is I think you're on the web. That sounds pretty funny. Now, they said there's been some work on getting APIs going on. And our RIX has actually provided an API for developers being part of this new economy, new model of website. But really, there's tons of content out there, and we can't get our hands on it through an API. So let's see. So there are some. The idea was like, there's this REST and there's 3D, and maybe we can put those two things together. So, but I really don't want to reinvent something. I wanted to see what the RESTful principles are, and if those could apply to 3D as a starting point. And here are the principles that one has to follow to make sure that they make an API that's scalable and has all these properties that have been demonstrated. And it's actually matched pretty well with what I want to do as far as REST 3D. One thing is you have a URI attached to a resource, so you can, with the URI you can point to a resource, and that's a good mechanism to get an identifier to specific assets. You can use, on the asset, you can actually use words that are in the header of the HTTP. You can put them as a new one. You can delete them, you can get them, and you can post, which means pretty much anything you like. There's some limits on what you can do in each of those. But one thing that's really important is actually that it's actually a representation-oriented model. So the server has all the data. The client needs some of it in some format. And you're not going to send all the data to the client for the client to find out what it needs to do and then finally display that. With REST, the idea is you have this stateless actually API that provides you a model in a very compact form of what the big data is, and then you can use verbs on those assets to get what you need. So it lets you do a lot of the computation on the server. This is the idea of cloud computing, where you don't want to move the data. It's more expensive to move the data than to rent a CPU on Amazon. So keep the data where it is, do the computation there, and then move only what you need. All right. So I thought it was pretty funny. This did not change, but if you show that with images, what happened to that? There's a lot of content. What if somebody using WebGL wants to get some content and put it together? First of all, you have to browse it. So web browsers are designed for browsing, and so that's what's happening. You go on a website, and that's a pretty cool website. The former Google warehouse, the Trimble and 3D Via and Outbreaks, and there are more. But you can see a lot of pictures and description. You can click on it and navigate, spend time on that. So that's the first thing you have to do. But maybe that's not the fastest way to find something, and you actually want to search. So search is actually pretty limited in those websites. Actually, Google has a very complex search box that I don't know if anybody has ever looked at, and it can fill up some in what you're looking for. But really, the parameters, what are the parameters you'd like to search? As a WebGL developer, for example, you'd like to know how many polygons in model is there in the loaded, how many textures it's using, what kind of, is there any shaders, materials. You would like to be able to ask those questions to the model before you have to download it and look at it, right? So that would be what search is about. Then, okay, nowadays you see no API, so you get to kind of a picture of the model. Our Bricks has a 3D view of the model. But even Google Warehouse, the 3D view is just a set of pictures. And 3DVI has a 3D view, but you have to download a plugin to see that. It's kind of slow. So you have a fairly good idea of what a model is, and you have to download it. And then now only you can start looking at it if it's something that fits you. So which one of the 10,000 Eiffel Tower available on all the websites you want to use in your, how long they're going to take to download all that and look at it, which one you're going to use. And then you need to bring the what I call heavy artillery, because you need to get your Max on Maya, which takes about I tried to learn it, and I gave up after 3 months, so I mean, it takes really experienced people to use those things to do something the right way, or you need to buy it, or, so you need to, take one of those very workstation-like heavy artillery tools to look at the model and see if it's what you need. And when you've done that, you may need to analyze it, you may need to fix it, you may need to combine them, and then you have your format that you're happy with, you can display in your WebGL, and then you want to publish it, and now you're on your own. And so we went through circle because there's no RESTful API, so you're on your own posting in those models in your own server and find whatever API you want to put there so you can serve the files. But before that, you need to export them, and so those are the variety of export. We talked about all different Cs and COLLADA format, but see, those are export. The export widget with those options. Which one are going to select to export? It's just mind-blowing, right? All that work, and you have to do that on. It's just a humongous amount of work and kind of add up and you have to do it locally on your own. There's no help there. So, yeah, pick your own poison to go and serve that content on the web. So the idea of the RESTful API is very simple. You have your client, you have the server, and in between you have the RESTful API. Okay, so the architecture at high level is very simple. Now, what goes in between? That's the whole thing we need to discover. And so I don't know yet, but what I need to do is I got some ideas, we discussed that, but I really want to build something to play with and design within that prototype. So that's what I've been trying to do. So what I've been choosing to do, and that's really my personal choice, none of those things are actually mandatory in any way. The only thing that we're going to end up doing is defining that API there. This is what I do, and I'm going to explain why. But we do need a server and a client. So the client, we're going to use a web browser, and a server, HTTP server, right? So the client doesn't need to be a web browser, right? It could be a modeling application or a game or whatever application that dialog with HTTP to use the REST API to get its content, right? Then on the browser side, I use WebGL, okay? Well, we could use Flash, you could use whatever, but using WebGL. I need some kind of a model view model where I can have my UI and I can act on the model and do things. And I found this thing called Tuxler, which is whatever. The thing about why I choose a technology is that I know none of them. I'm absolutely not familiar, so I like to learn at the same time. So I thought it was pretty cool. The one thing I like about it is like there's no CSS. We don't see the CSS. I hate CSS. I can't stand CSS. So this thing does all that CSS thing for me, and that's pretty cool. Now, on the other side, I need some HTTP server and a database, right? So I use Node.js, which I absolutely wanted to play with. It's fantastic. And you see, it's fantastic for what we're trying to do here, because if there's a way actually to send the processing of the content from either the client or the server, Node.js can help that because the same code that you could have on both ends. So that could be very nice. And also, there's a lot of cool libraries to do REST server and things like that. And then you need a database, so you pick up whatever you want. I've been using XML for a while with COLLADA, so I use an XML native database. One thing I don't like to see and I like doing are database schemas. I hate database schemas. they always, it's a lot of work and they always need to change and then you're stuck on something. So XML native database, no schema. You index every single node and then you do your queries in XML and you just, throw in anything you want and it's handling that, that's what database should be designed for, So anyway, so I use that one, that's called Basics, but it's actually a different one I'm used with, I'm used to something called Exist. But basically it's just an X-query engine, that's what it is. And then for the format, and you store things in some format. Now we could store in any format you want from the server, right? Because the idea here is like we're gonna find a way to make it work. So I use COLLADA because it only works well on my XML database, right? But we have images, we have shaders, we have a lot of other things that we need to deal with. Okay? So at SIGGRAPH, the group of people said, okay, it's all good, those ideas, let's try to focus on one thing, a viewer. So I was thinking, what's exactly a viewer and where do you start? I mean, is the COLLADA2JSON a viewer and we're done with it, or is that something more? So I'm thinking, well, what I really like to do is to be able to browse, search, the things that we have to do manually today. I like to do that through an API. I like to browse, I like to be able to search, I like to be able to analyze, and I like to view. And those would be very nice if I can do that through an API that anybody could use. So, those are just examples like what it could be. So, you need to return the list of assets. So, what is an asset? How do we organize them? How do you organize, how much, if the list is big, how do you send it so you only send some of that list? Then search, how do you search, what criteria are the search and so forth. Then returning a particular asset. So here's the thing that is very important. I know everybody here is aware of it, but the asset exists in different forms, right? And so what we want to distinguish from is the source of the asset and the asset you get to be able to do something with. So, and in between you got what's called content pipeline. So all that stuff, what the source asset, what you need for the content pipeline, that's all going to be, the idea is all going to be on the server. Or you can bring that on the client if you want to, right? But the idea would be nice if the server can do that for you. So how do we describe that? The next and the last is how do you control the pipeline? What are the options and so forth, right? So I'd like to put that together and make some examples. So for that, I started to build some kind of prototype. Let me show you. It's very crappy demo. So those things are important if you want to join the mailing list or check the website. It's open. It's not an IP committee. You have not to sign anything. You just run to the forum.
Post those to the meetup page tomorrow.
Right. And so you just say who you are and why you want to talk about RESTfully to anybody on the list, and then you're welcome. Okay. I don't know how to do that. Okay, I want to just bring. I can't see my mouse.
It's on the screen up there, so you dragged it across.
Okay. Right. So I guess I could take Chrome and bring it to work. Yeah. Okay, so those are the different areas that kind of symbolize the. This is Chrome and that kind of symbolize the different things that I want to do. So this is the asset browser, and then actually I copied that UI and some other tool. So let me know if you know which one it is. There's already a REST API that was called here to get that list here. So it's organized in like collections. But the collections, the collections are important because the assets have like kind of a path in their name. It's an XML thing, but they don't. Those folders don't need to exist really. It's just the name is composed of things with slashes in there, right? But it's nice to organize to represent them into some kind of hierarchy, and then so I have a way to actually send a request for each of those that you can just extend as you send another API call for getting what's in there, and then but they could be virtual. We could say make a feature of show me all the images, and then you have this virtual folder you click on and you have only images inside, right? It's totally transparent because it's not a hard drive that I have, it's just a database. And then I started to think about what assets we want to show. So to start with, let's start with the model, the images that we use to create texture with, and the shaders. So of course there are more, we can add more to that, and we can also maybe decompose some of those. But to start with, I want to start with that. And so the idea is that for each of those, I will have a control over what, more information on the asset and control over how do I want to get this in. So this is very small, but it says that there's actually two ways of importing, there's the source data, and there's actually two ways to build this data. It says one is using COLLADA2JSON, and the other one using the 3GS. And it could be any other things you want, kind of how you want to treat and build your data. So like I said, it's not build, it's all kind of fake, but it's
the format is going to be part of the request when we formalize the API.
Right. So how do you specify that? So when you click an image, same thing, because which of those, if you're and which target are you going to be on too, right? Because if you want to, you may want to use a format specific to iPhone or GXC format. It's important to do it that way because if I give you, a web browser can't do that on its own. Because if you ask for an image, you have to know how it is used. Like, is that a normal map? Is that a cube map? Is that an alpha? If you don't know how you're going to use an image, there's no way for HTTP as it is today to give you the right stuff. If it sends you back a JPEG and you don't have your alpha channel that you need, then you're never going to get. So that's kind of the idea of the recipe. Now, the other thing is up there you have your scene, right? And that's pretty much all you need. It's like you put objects in there and you combine them. And so the idea would be like you can take, that was not what I wanted to do, but okay, start with that. And so you could take, the only thing you can take actually is the models, and you can bring the models to the scene. And when you do that, they actually become more likely you can put a transform, for example. So you can put actually the same model on top of each other and so forth, right? And you can see that the view here is kind of very different. And this view is about combining those objects together to, and that's not connected. And there I've got my 3D viewer, which just runs on its own, but it's not connected to the eye yet. And that's the COLLADA2JSON. But basically, it is actually using the REST API to get the models and the bean and all that stuff. So the idea is that you could actually interface the scene with whatever. It could be a 3GS viewer. It could be and because this thing is just a representation of what this viewer needs. So the viewer knows how to do the REST API to the database to get the format it wants, and then it brings back the data needed for viewing. That could be a 3D printer, right? It could be processing data from database to send to my printer rather than my viewer. So anyway, so that's kind of framework I want to put in place, and then I'm gonna work on refining that to have a way to browse data, search data, organize, view your data locally, and then control your build pipeline. All right, so that's it.
We've got 5 minutes for Q&A with Remy, so does anyone want a question, comment? So I'll start. Can you enlighten us on what AMD's interested in this is, or how it fits into an AMD strategy that would allow you to do this as part of your job?
Well, I'm working on hardware acceleration on web browser at AMD, so that's kind of my main thing. And AMD is interested in that, obviously, and there's a ton of things that could be accelerated in the web. Now, 3D, even though there's WebGL and 57 people in that room, is not that all used over the internet. There's very little usage of it. And we're very interested in, this is an A10 APU, it's pretty cheap, and it's got a lot of graphics power to it. But if you use that on a web browser, you can see it's using that much of the GPU. So,
the general promotion of 3D content in web browsers.
Right, that's one thing. It's like making more, 3D more pervasive, which hopefully get the same idea with Google and Firefox and getting it fast. I mean, it looks like we're going through a 2D phase in the web, and soon we're going to rediscover 3D. 2 years from now, and I can skip that, please. I only have one life, so I don't want to wait more. But the other thing is, you see all that server thing? All this server thing. so there's a lot of process to be done. There's like image processing, compression, decompression, JPEG compression, you name it. There's a lot of compression, maybe even some graphics. And that's also an area where we could totally help and optimize and put hardware acceleration. The problem is, if you don't have a way to split, you know, if all the processing and everybody runs COLLADA2JSON converter on their own computer at home, and it's not exposed, and there's no client server way of doing that, then compute and graphics in the cloud itself, you know, won't grow that fast either.
So AMD also has an interest in that, if this isn't too much of a stretch, in cloud side of this as well, not just the client side.
So what was the choice going REST instead of WebSockets? Besides REST is not
well, you can. Well, I mean, the choice was that I was looking at not having something, and there's like a lot of research and demonstration about RESTful and what it gives you. So that's kind of starting point. The second thing is, I think that WebSockets are important within. They could be used in conjunction with REST-PD. But there's one problem with WebSocket is that I don't know how to cache, or maybe there's a way to do it, but caching is going to be very important with 3D models, right? And if you use WebSocket to transmit your data, it doesn't matter how fast you transmit it, because you're going to keep transmitting all the time. And that's a problem, because this room is going to be the same tomorrow when you come back to that room. There's no reason you're going to stream that again, however fast you do it. So WebSocket are probably are very important for, because you can push from the server, although you have long pools. So you can do long pool with REST. Long pool is like you put a request and you don't reply to it, and then at one point server is going to reply to it. Although you're limited to like how many 6 connections, or you know, you may.
WebSockets is better for the real time stuff.
Right. So, but definitely. So now imagine that section here. You have the scene, right? There's no reason why you can have a sandbox, a kit box there that says, "Yeah, I'm creating a sandbox. If you want to join me, as a URL." You go to URL, and all that work that we do in the scene is totally shared between several people. That would be totally.
Well, that's what I'm thinking is shareable scene.
That would be totally WebSocket. There's no question there. Now managing the assets down here, that's probably more REST thing, right? So you see, I'm trying to now that I have those different things. So this is REST. This is COLLADA2JSON. So it's streaming the bin. Right now it's doing. I forgot the name. THR. Calls. It's putting the same file with different. I don't know how well that works with caching either. When you keep asking for different segment and file.
I mean, that may work,
I
but
don't know. I just study that, right? Yes.
You got a lot of parameters going on to the server requests, right? So the reply is dependent on a lot of variables. Is that true that are going into the server? Because you've spoken about having a city model of downloading only the portion that's you frustrated right now.
Right.
Nearby.
Right.
But the thing is that is completely incompatible with how web browsers cache HTTP requests today. I mean, the caching of web browsers is so rudimentary that if you have part of the response headers coming back that varies based on something like the origin of the request, like for cross-origin resource sharing, it doesn't get cached at all.
Right.
So, yeah, I mean, I think Adam's question is really pressing because it's like, well, if the browsers aren't actually going to do anything useful, then maybe we should just throw out all the technology that's in the browser and do it ourselves at the application level.
Why not? So, yeah, I really like to know and study that, and so that's why I do that prototype too. But yeah, I agree with that.
So let's bump up a couple levels and talk to the group about what our next set of initiatives is. What's our plan? What are we doing? And I'm asking him, like I'm the coach, but I haven't done jack here on this. So, I mean, what do we think we're trying to do with it? Last I checked in, we were looking at use cases.
Right. So we did
before you
use
joined
cases,
AMD, right?
Right.
So how do you see the agenda shaping up over the next few months, and how can people get engaged and involved?
Yeah. Well, I can use help for sure so I'm trying to take the use case that we were imposed by the different people in the room because I wanted to do modeling, collaborative modeling and things like that, but that's not what people said was the most important today. So and I look at how people are doing today, the browsing and packaging an asset into
so browsing and discovery of models out there. And so I find models of some type that do something that
now from that point, I'm interested into benchmarking. I like to know how caching works. I like to know how fast this thing is displaying. I want to know what format is better than another. I want to know. So really, once you start looking at performance, you can build. There's no reason why you couldn't have a set of scenes flip through, right? And then you can build benchmarks that way, and you can see, see how fast it renders with that, this type of model, this type of shaders and so forth. So that could be very interesting too. That's something I build some, and hopefully I can build something that's useful. So because there's no reason why you couldn't have like a virtual folder like a Google warehouse here, which doesn't have a REST API, but there's no reason I cannot build a proxy to it and funnel it through a server, which I did in the past with a few other servers. So you can get an open source software that can give you access to most of the assets in the world in that format, in this UI, where you can't just grab it and look at it. And then we'll see where it goes from there.
Nice. Okay, great, thank you. Wait, we got one more.
Yeah, is the code on rest3d.org?
No, the code is very happy now, so you don't want to look at it. But yeah, I really like to. It's gonna be open source. Yeah, I don't know how.
So you put on GitHub or something one day.
Yeah. That's the plan. My boss said, "Oh, you want to make that open source?" He asked me. I hope it's gonna be open source.
So good. We should get on. We should do that sooner rather than later. Okay. So Remy will post URLs to this stuff the next day or two. I'll prod you on that.
Yeah.
Great. Thank you so much. As we can see, there are a couple of great infrastructure tool initiatives going on here that I think are going to support the growing ecosystem. So I hope some folks in the room are techy enough that they want to get involved in helping on those. Everyone needs some help either at the spec level or code level with all this. And I'm glad Remy's found a place that sponsor this in AMD to work on this for a while, because he and I were kind of doing it on our own for a while, and I went off and did other things. So glad to see you're doing that now. And I encourage anybody who's of a like mind to please communicate with Remy and get on it with us. So Mark said we got the place for another 20-25 minutes, 9:30-ish, so we can still mingle. Before we break up officially, I wanted to bring Mark back one more time because he has a quick plug about something.
Yeah, it's a quick plug. We're starting to open up the SDK for Cubify for our website to developers. It's in private beta right now. So what that means is if you're interested and want to get tapped into 3D printing, we can give you a connectivity to the website so you can actually print things and provide models. More importantly, we actually provide the MyRobotNation engine as an example app for you use the dependence app that we were showing. We actually basically say, here it is, here's how we did it, with all the tools and all the things that go with it, all the JavaScript, everything. So it's in private beta right now, so you sort of have to come and ask me. So, but if it's something you're interested in, come and ask me, and we can try to figure something out. We're starting to give it out to people.
Awesome. Oh, all right. So again, thank you to our hosts at 3D Systems. Sarah, who had to leave unfortunately. Our great speakers, Ken, Fabrice, and Remy, and our sponsors, Kronos. And you guys are awesome. This is the last one for the year. We're going to set something up for probably January. And suggestions welcome for what the next one should be. And have a great end of year and holidays. Thank you.